Hello everyone, welcome to my session at Oracle Database World on all the great new SQL features that we have added to the latest version of Oracle Database. My name is Keith Laker, I am the Product Manager for Analytic SQL. My Twitter handle is on the left there. If you want to reach out to me, that would be great. As we've got a short time, let's dive in as quickly as we can. Of course, all of the new features that we have in the documentation for this version of the database, so feel free to follow that link at the bottom and explore all the great new features that we have. From a SQL perspective, there's a lot of stuff that we've packed into this version. Let's start on the sort of general side. Don't have to do anything, all you have to do is run your query and you're going to inherit automatically a whole series of amazing processing enhancements that we've done that will just speed up your queries. So don't be surprised when you upgrade to database 21C if your queries just run faster without having done anything. If you want to take advantage of some of the new features, and some of these are really high performance features, then let's dive in. Okay, a lot of you use some of the Oracle syntax when you're writing your queries for set operations, but a lot of you want to use the standard ANSI syntax for these types of operations. So we've listened to what you've said and we've extended the capabilities that we have inside the database. So we now accept things like accept and accept all operators within your queries for doing set operations, and we've extended the intersect and minus keywords for set operations to also include the all. So this is kind of useful if, not only to make sure that your code is ANSI compliant, but most importantly if you're bringing workloads over from other database platforms. Now this is a series of changes that you just bring the code in and it will work inside the Oracle database with no changes. So that's a big win. Next down the list, bitwise aggregators. So in an earlier release of Oracle database, we did some pretty significant enhancements to speed up count distinct processing. A lot of people asked us, how have you done that? Is there any chance we also do sort of bitwise operations? And could we have access to some of the features that you've used to drive distinct count processing? So we've opened that up. So there's three different operators that we've added. So if you've got sort of typical binary, event stream, Internet of Things type stream data sets coming through, or maybe in data science where you've got lots and lots of attributes and essentially you end up with lots of these binary flags, and sometimes you need to do operations on those. We've now got three key new functions, capabilities there for you to use to speed up your processing. Interestingly, if you're wondering what that image is doing on the right hand side there, if you sort of Google bitwise aggregations, what are the typical use cases? One of the most common use cases is actually internet dating apps, where you go through the sign up process. You're tagging lots of these predefined attributes to say whether you like running, you like movies, and so on. And then all these apps use bitwise aggregators to then make all those matches. So if you were wondering how internet dating is largely driven, it's using bitwise aggregators. DBAs, one for you. So I'm guessing a lot of you get requests during the day for, I need access to DBMS_SQL hash so I can do a checksum. Because I need, for example, regulatory requirements to make sure that a data set, a data item, a row, column doesn't change. And I need to confirm that that is actually the case. So I need access to DBMS_SQL hash. Good news is no more processing of those I need requests. You can now use the checksum function. So you can just point your developers, your business users, whoever it is, to the SQL checksum function, which works in exactly the same way, but the code's much simpler now. You just call checksum and the column that you want to do the checksum on. And that's it. So bit of a taking the load off your shoulders there, folks, which is good for those of you that are sort of more into the big data stuff, the data discovery type projects. We got some cool features to help you as well, sort of get you started, point you in the right direction, if you like. So the first feature we've added is something called SKEWNESS. So SKEWNESS, if your SKEW value that's returned from the function is positive, your data is skewed to the left. If it's negative, your data is more skewed to the right. And if you get 0, you've got a perfect normal distribution. Now, bearing in mind that we're kind of doing data discovery here, sometimes the data set's huge and you want a quick answer. So we've given you a sample option as well. Just pass the table name in to the sample version of SKEWNESS and we'll execute that query much faster for you. It's pretty accurate, and if you do some tests yourself, you'll see it is pretty accurate. So it's a good sort of like first step. Just give me a rough guide as to what this data set looks like. Next one is KURTOSIS. So this gives me some information about the tailedness of the data. Where are the variations? Do I have lots of small variations? That's going to come back as a lower KURTOSIS. Or have I got very few huge deviations? That's going to come back as a higher KURTOSIS. And of course, again, as in the previous example, if I got a normal distribution, it's 0. So if you look in the example on the right there, you'll see channel 2, for example, has got a much, much higher KURTOSIS than channel 9, which tends to indicate that channel 2 has got deviations, not too many of them, and they're more likely to be extreme compared to channel 9, which has got some deviations, but there's probably lots of them and they're probably quite small. So these are great sort of, let's get me started with this data set. What should I be looking at? Where should I be directing my analysis? Next set of features, again, is an extension bringing us in line with ANSI SQL 2011. Window functions. A lot of you are probably using window functions, you know about rows and ranges. Some of those restrictions that apply to whether you're processing by row or by range. Take all the good things from the two of them and put them into a single feature, and it's called groups. So that's an additional keyword now. Again, it's going to help you where you're either need that functionality, you need to combine the elements of rows and range. Groups will allow you to do that and give you more flexibility, or simply where you're just bringing over a workload from another database that already has that capability. You're not going to have to make any changes to your scripts. The other nice thing here is we've got this shortcut. So we've given you the ability, it's a bit like what we do in SQL pattern matching actually, where I define the pattern that I'm going to look for, and then I just determine with a letter or a string of letters how often I'm going to look for that thing. We kind of done the same thing here. So I've got two window functions in the query on the right there. I've got a sum and I've got a count. And what you'll notice is there's no window clause. I simply say over W. My question is, what is W? Well, W is defined towards the bottom of my SQL statement, and I just then lay out what that window clause is. My partition by, my order by, and in this case I'm going to use a groups function. And if I need to make changes to my window clause, let's say I want groups between 5 preceding and the current row, I only have to change it in one place now. I don't have to go searching through all those column definitions to try and see where 4 preceding is and change it to 5. Just change it in one place, and you can have as many of these sort of window shortcut references as you need. So really, really powerful, very, very flexible. We've also introduced the EXCLUDE capability. So I could do, for example, sum over rows between one preceding, one following, excluding the current row. So essentially I'm just looking at the row that's coming before, the row that's coming after, and I'm ignoring the current row when I'm doing a calculation. Very, very powerful, very, very good. Okay, the big one. This is the big feature. This is like my marquee feature for database 21C. The good news is, if you're running database 19C, we had so many requests, we backported it. So if you're on patch set 19.7 or later, you'll have access to this feature. And it's a really good way for like DBAs, PL/SQL developers to take complex code and wrap it up and give other developers, business users, something much, much simpler to work with. So consequently, there are two sort of places where I could use a SQL macro. I could use it in the where clause or a select as in a column. And that's a SCALAR macro. And it's similar to calling a PL/SQL function, with one big important difference that we'll come to in a minute. The other one is probably something that everybody's been searching for, is a really easy way to, in effect, encapsulate a table, to create a result set through a table and use that in the from clause of a SQL query. So let's have a look at SCALAR macros. Everybody's probably thinking, I could do this before I had PL/SQL. You did, but the big challenge was that when you used PL/SQL, we got this context switching. So as I moved from the SQL world into the PL/SQL world and back again, there was sort of you could lose a bit of time while you did all this switching. What SQL SCALAR macros do is eliminate this PL/SQL switching process. So now everything is encapsulated within the same snapshot, and in effect the whole query gets transformed into a much larger SQL query by swapping in the SQL code that's within the SQL macro. So if you see on the right here, let's take a really easy example. I've got a Postgres database. I want to move that to Oracle. Guess what? I've got loads of scripts where I use string pos. Oracle doesn't have string pos. We use in-string. How do I get around that problem? I could write a SCALAR macro called string pos, which accepts two parameters, the string and the substring that I am searching for, passes that in, and what the macro does is return the in-string equivalent. So we'll do in-string, string, substring, and that's what you get back. And when you run that Postgres SQL query, that in-string substitution will automatically happen at the SQL layer. So this is great, because what this also means, now this is all operating in the SQL sphere, is where we've got additional optimization, such as those of you that are running engineered systems, for example. A lot of this processing can now be pushed down directly into the Exadata storage servers. So huge performance boost. Now table macros, again, everybody's thinking, oh, I had all this. We had this with polymorphic table functions. Yes, we did. We also had it with data cartridges and so on. But they were, how should we put it? They were very sophisticated and very powerful, but they also took a lot of time to set up. This, as you can see here, much simpler. I define a function as I did before for a scalar function, except this time I tell it it's actually going to be a macro of type table. I pass in a parameter. In this case, I'm going to pass in my department number, and I have a default in case my user doesn't give me anything. And then the macro is going to return a standard SQL query every single time. So it's going to work out what the department number is, what the sum of the salaries are, the department name. It's going to find out what the total head count is, total number of managers, and return that as a query. So now I can just give my users this new table, in effect. Looks like a table, feels like a table, runs like a table. It's called budget. It's a SQL macro. All my business user has to do is give me the department number, or give the budget, the SQL macro, the department that they're interested in, and it will run that query for them behind the scenes. So I've wrapped up this whole query into a single call that can be embedded in the from clause. So that's one type of SQL macro. The second type of SQL macro is table. SQL macro is a lot more flexible. So whereas on the previous example, I knew what the table was and I knew how many columns I was going to return, I can actually take this a stage further, and going back to what was polymorphic tables, I can also inherit some of the flexibility from that by calling some of the packages that were part of polymorphic tables and use that to, in effect, create a completely flexible return statement. So you'll notice here, let's say I've got a whole series of data scientists. They're always wanting to get training sets to test their models out on. They effectively want to take a sample. They each have different sample sizes that they might want to run with, and they just want to give them a simple way to pass in a table name and a sample size. Well, the macro on the left there shows you how you can do it, and the output is on the other side. So I give this to my developers, my data scientists, my business users if they're also wanting to do this type of operation, and they can just say select star from, and then sample is the name of my SQL macro, my table macro. I pass in the table, in this case sales, and the percentage, I want 15% sample. So very, very easy now to encapsulate quite complex, sophisticated logic and make it available to non-technical, or provide other users with a much easier way to process that logic in a very easy to consume way. So this is tremendously powerful. There's a lot of sort of layers to get into here. So there's a blog post available that I put on the data warehousing blog. If you get into that, I'll go into all of the stuff about what happens when the SQL execution plan, if you look in there, and what you're seeing and how the transformation is going forward. So that's a good deep dive if you want to get into it anymore. That's it. Thank you very much for listening. I hope you're enjoying this series of videos around database world. If you need to get in touch with me, my Twitter handle's there. Feel free to ping me via email as well, and enjoy the rest of Database World. Thank you very much.